The Mythbusters are going to have a blast.
The most common theory about what's going on in this reaction between the candy and the soda is what's called nucleation. Basically, the idea is that the surface of the candy is covered with microscopic pits and lots of more surface area than you can actually see. And each little pit, each little corner provides what's called a nucleation site, or a place where a carbon dioxide bubble can form and escape.
Look at a Mentos close up, and it's like the surface of the moon. And that might be the candy key. Drop one in cola, and every tiny crater provides a site where a CO2 molecule can change to gas. Because Mentos are so pitted, the theory is that millions of CO2 bubbles are formed in a very short space of time. And because the candy sinks and this rapid release of gas happens at the bottom of the cola, you get that famous fountain.
EP Bird has taken a stupid human trick that used to be found in fraternity houses and made it a career. The tall one's a lawyer, the bearded one's a juggler, and now both tour the world exploding diet soda. We decided to bring EP Bird to the laboratory for some action of our own. Just what happens between the time a breath mint hits the soda and the whole thing explodes? In order to find out, we've got to get warped.
It's a scientific process called nucleation. It's a physical process, not a chemical reaction.
Inside every half-gallon bottle of soda is dissolved about 1/3 of a cubic foot of carbon dioxide. And those bubbles are yearning to breathe free.
And what's happening is the CO2 is looking for any crack, any surface, any bump anywhere to start forming a bubble on. So if you put your finger in, you'll see it forming on your fingerprints. If there's a crack in the glass, you can see it forming right in the crack in the glass. And the Mentos have so many little points on them that they're just perfect for this reaction.
Normally, this reaction is instantaneous. So we need to get warped in order to learn the secret behind the spray. First, to get a really good look, we're going to use clear diet soda, which also works pretty well.
Well, that's already looking pretty cool. You can see all the nucleation sites on the glass, but I have a feeling we're going to get a bunch more in a second. So one Mento is a Mentos?
Yes. It is, actually. Technically speaking, one Mentos.
Always curious.
Do they travel in herds or packs or gaggles?
Packs.
It's a gaggle.
Packs of Mentos.
Thank you.
Are we set?
Yep.
All right, I'm going to lower the Mento.
Drop it in.
Release the pressure.
Oh, yeah.
Oh, that's great.
There we go.
Oh. Frothy. It seems like there's bubbles forming at the bottom that kind of drag across the whole surface and pick up more and kind of release them all together.
And it's all about that rough coating of the Mentos. All the carbon dioxide in the soda is physically drawn to the surface of the Mentos, which is covered with tiny little bumps. There's 40 layers of sugar on the surface of that Mentos.
And that makes for a really, really bumpy surface microscopically.
So once they create pits and the carbon dioxide is reacting with them and it wears it away, you get more nucleation sites. So at first, it's going to speed up until all those nucleation sites get depleted. And you can smell the mint and the Sprite at the same time. It's a great mixture.
Minty freshness.